Okay, folks, why don't we start? So my name's Reid Priedhorsky. I work at Los Alamos, and we're going to talk about Charliecloud and how it's kind of quirky. I always like to show this slide. I think that you've probably seen it. Megan, Dion, and Angelica are right here, so ask them all the hard questions. I think notably this is not a Charliecloud pitch. This is more me thinking about how I think containers should work for HPC, and Charliecloud is an embodiment of that thinking. That does get conflated sometimes, but I tried hard to make this not a product pitch. Okay, so then what are we going to be talking about for the next 40 minutes or so? I'll talk a little bit about how containers work, bring people up to speed. This is what we call the philosophy of Charliecloud, so this will be the meat of the talk. This is a kind of unusual approach to containerization, and we'll talk about that. Some of the examples aren't quite as tidy a fit as I might have hoped, but they should make a reasonable amount of sense, and then talk about why I think there's value in being unique. All right, so let's start with containers. The basic argument for containers is that it's a process or a group of processes that have their own view of some kernel resources, right? The key ones, and we'll talk about this, is the file system tree and then user and group IDs, right? This is a tidy way to either bring your own software stack or lately whatever the vendor has provided, and you can withhold your opinions on how much you like it. We'll hit this a lot too. In my view, containers just processes, right? Containers for science applications, the value is that this encapsulation with almost all the dependencies that makes deployment easier, right? The Linux kernel itself is a big exception. Usually it doesn't cause trouble. Sometimes it does. Then the other piece of this is that as we see newer types of applications appearing, a lot of them, they assume containerization. Like you talk to NVIDIA and you're like, how would I run your thing without your container? And they don't know what you're talking about. There are many container implementations. We're not going to go into this slide in too much detail. The thing I want to emphasize is that this is different privilege levels. And we like a type 3 container, what we call a type 3 container because of the unprivilegedness, right? This is the only way to get a fully unprivileged container workflow through the whole thing, right? So then what is Charliecloud? It's not this guy. It's a lightweight, fully unprivileged open source container implementation for supercomputers, right? There's one capital C. It's one word. There's no camel case. I just mentioned that because it's really easy to misspell, as I've discovered. We do support the entire container workflow, so building, pushing, pulling. We can help you deal with accelerators, proprietary interconnects also fall into that area. And I mentioned we have a unique approach, but we do compatibility where it's important, as far as I can tell. Okay, so then this is our GitLab project. We're on GitLab, not GitHub. We have a website. It looks pretty decent. We have documentation. It looks okay. It's pretty extensive. So then the components of Charliecloud, we have kind of 3 and maybe a 4th that's growing. So chrun is the actual container runtime. This is a C program. We have chimage, which is a Python program, and that does the stuff that's, I guess, harder to program, right? So this is our Dockerfile interpreter. We use this to push and pull the registries, things like that. Then we have a reasonable amount of glue code. This tends to be shell, and we try hard to make it POSIX rather than bash or associated with some other shell. 4th component, Angelica has coded up a compose, which can let you run Docker compose files, which is pretty cool. And that's another type of thing that we're starting to get, that people want to run multiple containers at the same time and have them interact and have dependencies and stuff like that. And she's speaking tomorrow about that. We also have a prototype of Charliecloud as a Kubernetes runtime, because sometimes we see that as well. That was also an Angelica thing. This is all fairly small, right? So all told, this is around 11,000 lines of code, which I think is cool. So then we can get into the first part of the Charliecloud philosophy, right? So that's transparent, not opaque. And I'll give sort of like some arguments about the idea, as well as some specific examples of decisions we've made based on that that part of the philosophy, right? So things should be explicit rather than implicit or magical seeming, right? So be honest with the user. There's other stakeholders as well, but we want to be honest and straightforward, right? And one way to think about that is that users aren't stupid, but they are often ignorant in a non-pejorative sense. And further, generally they want to get their science done. They don't want to learn about the computers, right? There are exceptions, but this is the modal response. If you can't explain something clearly to the users, maybe you have some sort of underlying design problem. So I think about that type of thing. There's also this notion of a dual audience, right? This especially comes up during troubleshooting, right? But your audience is not only the actual users, but then also the nerds that help them, right? So, for example, this comes up in error messages, right? I think a lot about the error messages. I want them to be accessible to users and also correct, so that somebody with more technical knowledge can come along and look at that error message and like understand what's happening and help fix it, hopefully. Same deal with the documentation, right? We want to explain clearly and also completely how to use it. The downside there might be that our documentation tends to be pretty verbose, but my hope is that you can skip the parts you're not interested in. And again, if you can't write documentation that explains what it does and how to use it, you might have a problem, right? Also, like how it actually works, to the extent that the audience actually needs to understand that, why we made key design decisions, those types of things. I think you can't read that at all, but the one amusing thing I think is that we actually have a FAQ entry on how to read error messages. And now you don't need to read this in order to understand the error messages, but there are very specific components to the errors. And you can go in and look at this. Like we include the PID. There's the source file and line number in error messages, every error message, because that might be helpful for anybody to debug. And hopefully folks who don't care can ignore that. I mentioned that containers are just processes, right? So what are container ingredients? Linux namespaces is sort of this is the key thing. I mentioned that this gives you a personalized view of kernel resources, and the way I like to think about it is a bucket rather than a prison. It's more like for getting your thing done than keeping everybody secure, right? There's a bunch of different namespaces, so there's different dimensions you can have your personalized view of in. So mount is your file system tree and mounts. You can have your own process IDs. You can have your own network stuff. There's several. And then there's this user namespace, which gives you your own user and group IDs and also capabilities, if you know what that is. We divide these into two categories. So most of them are what we call privileged namespaces, in that you have to be root or have certain capabilities in order to create these namespaces, unless you're also creating a user namespace at the same time. And then you can create unprivileged versions of most or all of these. Now the key is the file system tree and mounts and the user namespaces. So that's all Charliecloud does. This lets you do the actual container thing. Now other container implementations, Docker, Podman would be the most notable ones. They also do a lot of process management stuff, right? So that's like C groups for resource limitation. There's security layers, SE Linux. There's a supervisor process that supervises things. We'll get back to that later. Lets you start and stop services. Can do scheduling. Container people like to call it orchestration. I've never 100% understood the difference here. Not 100% convinced there is one. In my view, this is separate from containerization, and HPC is already good at process management, especially if you work in like workload management or something like that. You think a lot about this kind of stuff. Container images, they're just directories and files, right? So this is a container. It's just it's not a container. It's a container image. It's a directory in vartemp. We can run this image, right? So we just do chrun and we give it the path, and then we give it a command, and it does its thing. Other container implementations will be boiling it down to this somewhere. Somewhere they're building a directory that they can then run. It's just tends to be more opaque. Charliecloud has this notion of a storage directory that we do all kinds of like working stuff in it. One of the things that we have is this subdirectory called image, and inside it there's a bunch of images. Those also are just Linux distributions in a directory, right? So I find that thinking about container images in this sense simplifies my life a lot, and it's more transparent to what's actually going on. The other belief I have is that Unix is right about a lot of things. So the core of Unix is considerably older than I am. Maybe not considerably, actually. We're not going to talk about that. The core concepts of Unix I really like. They're elegant. They are still around for a reason. So this is things like processes. Everything is a file. Files are unstructured. It's just a sequence of bytes. We have a single file system tree, like in contrast with DOS and Windows with this drive letters notion. The API for Unix is pretty parsimonious. And nowadays, of course, Unix almost always means Linux, but it's the same idea. So some corollaries here is that newer is not always better, right? Sometimes it is, sometimes it's not. I really like to think about it in terms of let's innovate in order to create value, not just to be new. There's also this, I think this is often labeled the philosophy of Unix, that we want to make each program do one thing well. So this is why I think process management should be delegated to something other than your container runtime. Another view on transparency is that scholarship matters, right? So some concepts that we have have explicitly brought into Charliecloud are like Docker files. We have a formal grammar for parsing Docker files. I've not been able to find one anywhere else. There's a Python library that we use to parse it. This thing that has come up recently in the past year or two is everything is a DAG. So that's a directed acyclic graph. Images form a DAG. Our development forms a DAG, the Git thing. The test suite, turns out it's also a DAG. So we had a student working on that. We also go in the other direction. So we publish. We have 5 papers, unless I've miscounted, with a total of 300 citations, which I think is actually pretty neat. All these are open access. So let's next talk about simplicity, right? So one of our goals is to stay small. I think this is a screenshot from an unpublished paper, and it is a bit old. This is a few years old, but the gist is the same, right? So this last line here of the table is lines of code. This is different from what I quoted earlier because it's a different subset of the source code. I think this is everything. The last was the program itself. That number is now 36,000. But then you'll notice, you'll look at some of the other implementations, and those are a lot larger. So I mentioned that we do minimal namespaces. We also try to do minimal dependencies. And so some of the things that gets us is Charliecloud hopefully is accessible to humans, right? One person can actually understand the code. We can maintain it. We can, it hopefully can be adapted to multiple workflows. We try to avoid vendor lock-in. you could fork Charliecloud. I would be really impressed if somebody managed to fork, for example, Podman and have it like actually work. There's no vendor attached. I mean, there's the Charliecloud team, and we have opinions. But what we don't have is salespeople. We don't have a large, complex system that we tell you it does everything, and then you can discover what it doesn't do later. Charliecloud doesn't do layers, and this is a little heretical. What we do is we think about, and I'm not going to go through this whole slide, but you start with an empty image and then you modify it in various ways, and you end up with a tree, perhaps a tag in the future, and we're like, okay, well, let's think about it in terms of a tree rather than layers, right? A layer is just a diff. Git is really good at trees with modifications, so we put our build cache in Git. We have a cool paper about that. Squash views. So this is, Megan did this one. This is more like a workflow simplicity, right? So Charliecloud will mount your squash FS image internally, unmounted internally. User doesn't have to mess with mount and unmount stuff. We also try to lean forward on Linux features. So some examples of that, unprivileged user namespaces itself. When we did it, this was quite new. And we actually had to argue fairly extensively that it was a reasonable and safe thing to do. Nowadays they're more routine, but we were doing this in 2015. There's a thing called reflinks, which is more or less a copy on write hard link. So that's really cool. Still supported by only a few file systems, but we can use it in our build cache for large files. To me, that's really cool. We do unprivileged overlay FS, which is also kind of new. This is for an option called write fake, which makes the image look writable, but it's actually not. And this enables things like a squash FS image, which is read-only format, but it looks writable. That's cool. And the thinking here is that we want to reach forward, like just enough to get that thing that simplifies whatever, but still remain compatible, right? Like when we first were using unprivileged user namespaces, we had to get a custom image for the supercomputers because TOS version whatever didn't have the right kernel at the time, right? But it was clear that it was coming, and this was the way to do it. And now it's routine. Be unprivileged. Okay, I like this to-do list. I wish I could use it every day. Avoid responsibility, right? So a somewhat less facetious way to pose that might be that writing secure code is hard and it's risky, right? But other people have already done it, and they're probably smarter than me, so we don't have to also do it, right? In particular, there's a lot of really smart eyes on the Linux kernel in keeping things secure. So you could go to the system admin perspective for that type of thing. So fully unprivileged containers work, right? This didn't used to be the case, but now they do. That includes the whole life cycle. So if that's true, why do you want to maintain additional programs on your system that have to run privileged, right? Linux access control works, and this is not just traditional Unix permissions bits, but it's newer stuff too. You got ACLs, you got these AppArmor and stuff. So if this works, why do you want a new security boundary to maintain and protect, right? So based on that, we're like, okay, well, we can do a fully unprivileged end-to-end workflow. There's no root. You don't have to sudo anything. You don't need setuid or seccomp helpers. This is the new UID and new GID map programs that you need to configure And if you do it wrong, you will unsecure your system. We don't maintain a security boundary. As far as I know, unprivileged run was an industry first. Unprivileged build was an industry first. And something else that we do that is kind of subtle is our fuse is fully unprivileged. Like if you look on your system, you'll find that this helper program, fuse or mount, has the set UID bit. We actively suppress that when we call it, and I forget like which little magic we do, but for Charliecloud that bit does not count, and I think that's neat. So for example, you occasionally see security advisories about container escape. If it's a type 3 fully unprivileged container, this is just not a thing. It's another unprivileged process, right? Root emulation. Okay, so this is a fun story, right? So anyone in the room have children other than me? Gee, all right. They're a hoot. Anyway, so let's talk about Jerry. Jerry, go brush your teeth. He wets his toothbrush. He squirts a little toothpaste down the drain. He lets the water run for exactly 2 minutes. Maybe some of you at least have nieces or nephews, but like the children are terrible. He might even make a few age-appropriate spills on purpose, right? And then you go back to Jerry and you're like, did you brush the teeth? Sure, yeah. And if you check up on him, you will see evidence of teeth brushing, right? So these are, where are we? Okay, right. So let's talk about Terry. You tell Terry, go brush your teeth. Terry does nothing. You go back, do you brush your teeth? Yeah, sure, I did it. These are consistent lies, right? Because there's evidence. These ones down here are inconsistent lies. So then, how do we get back to the root emulation, right? So there's this thing called seccomp that will filter your system calls, and you actually write a program to analyze the system calls. This is the pseudocode for our program. From the process's point of view, the system call was successful because we intercepted it, did nothing, and returned success to the program, right? So then this is relevant for like package managers that like for decades have assumed they actually have root privileges. So they do all kinds of things that you can't do in an unprivileged user namespace. So then the question is, do these package managers need the root things that they're asking for? Do they need them to actually happen? And the answer is generally no, which ended up a pretty spicy abstract. Elena is going to be talking about this type of thing more tomorrow in this room. So go to her talk. She's really smart. All right, play well with others. Fourth piece of a philosophy, right? So thinking about compatibility and interoperability, in my view, there's more to it than just do the container things, right? There's other pieces that we care about, specifically, the science applications. The Venn diagram going on here, we got science applications, we got the services. There's a small amount of overlap right here. It's not zero. And then there's this thing about containerization. So if you take your normal, sort of like a routine container implementation, especially if it's trying to be OCI, they're mostly about services, right? If you're lucky, you might have this small area here of like, they say that they can support HPC, but it depends. Apptainer is going to be an exception. I'm not sure actually where I would put it on here, but it is. They're not coming at it from the OCI perspective. Charliecloud, we try to live more on this side, right? So it's kind of like we oozed from HPC up into containerization, right? And the thinking is that this blob, the blob being smaller, lets us have a clearer focus, and that lets us have lower overhead in terms of both technological and usability, right? So then some challenges to interoperability. HPC principles versus sort of like cloud assumptions / principles, right? So one being privilege, right? So if you hear from like an HPC center, you probably heard about the principle of least privilege like over and over again, that users should be given the most limited access that they need to get their work done, right? That's been around for a million years. I think it's kind of self-evident. If you're in a cloud, you just get a virtual machine with root, right? So that's different. HPC centers tend to have varying security practices of different levels of obnoxiousness. One that comes up a lot is internet, right? And that could be anywhere from you cannot reach the internet at all to you're reaching the internet through some strange filtering thing, or like maybe you have to call consult every time you want to add a new website, stuff like that, right? If you're in the cloud, right, you have your own VM and there's firewalls so that you can't talk to the next VM on the system, but after that, you can do whatever you want. Usage model, right? So HPC is used to persistent shared systems, right? You log into the front end, there's 20 other people logged in. HPC has shared file systems. We use UNIX permissions to separate folks' data from one another. Cloud, you have virtual machines that are ephemeral. They appear when you need them, they disappear when you're done. They don't share anything unless you set it up during your own initialization process. And there's these data access, various data access things that are done over HTTP in one way or another, right? Networks. So HPC networks tend to be fairly fancy. I could have written this interprocess communication as well, but in particular, between the nodes, you tend to have some very fancy, low latency, high speed network, right? You also have processes on an individual node using some kind of shared memory to talk to each other quickly. The vibe in cloud is that everything is done over TCP/IP, right? Coupling of your parallel programs, right? So both of these tend to be extremely parallel, right? With HPC, it tends to be a relatively small number of jobs. Each one of those jobs is itself very parallel, and they're closely coupled, right? So, for example, we spend a lot of time chasing down slow nodes, because if you have an MPI program, it runs at the speed of the slowest node. On the other hand, cloud tends to also be extremely parallel but loosely coupled, right? So if you have a million web searches going on at once and one of them falls over, the rest of the compute doesn't care, right? So loosely coupled. Architecture in HPC, we often care a lot about the specifics of the architecture of your machine, and that's not only which specific processor you have and which specific like instruction set extensions it has, but also like which GPUs and which revision of the GPU, and how's the memory laid out, and how many NUMA nodes there are, things like that. In cloud, generally you set which high-level instruction set you are getting, and that's all you know. You can check using system calls, but you can't ask for it beforehand with much granularity. Data center features. So I talked about the high-speed networks. Parallel file systems are also a thing. HPC centers have these giant, like Lustre, Parnassus, or whatever. I think that dash is a little misleading in cloud because it also offers various things that you're not going to find in an HPC data center. But I'm coming at it from the HPC side, so I put the things that were important to me. Another one is capacity, right? So HPC data centers are finite, and users know that, and it's very obvious to them, right? Cloud data centers are also infinite, or are also finite, but they work really hard to pretend that they're not. And then so my argument is that this HPC way here, this is a reasonable way of doing things, right? And we shouldn't just throw it out because it's old, right? That brings us to Open Container Initiative, which is it's a container thing. If you're not familiar, it's actually 3 different specifications. You have the image specification for container images that you can, I guess, move around and stuff. There's a distribution spec. This is how your image registries work. If you're pushing and pulling, you're talking to an OCI registry using the distribution standard. Then runtime spec it's a container lifecycle and how exactly that works and how you talk to it and stuff. This is considered the standard for containers, right? So, do I like OCI? The short answer is no, and I'll explain a little bit about that right here. Some of that comes from just clashing assumptions, like I talked about a bit earlier, right? So we have this usage model. HPC is looking for scientific insight. OCI is designed to run services, right? The process model is also different, right? HPC, it's the UNIX processes. We have a process tree, right? Process has children and children, et cetera. OCI considers containers to be a persistent thing with a fairly complex life cycle, right? That means that if you want the container parts of OCI, it's hard to not also collide with process management stuff. We talked about the privilege model. Specifically, it is not possible, as far as I can tell, to actually be OCI compliant if you have an unprivileged runtime. And that is because OCI containers can ask for things that you can't do as a type 3 container. Then I talked about the architecture model a bit too. ArchSpec is a really neat library that I wish I knew more about, but there's a cool paper about it. You can also get into what I see as design flaws in OCI. So I talked about how I don't think layers are fundamental to containers, but they're really embedded in, as far as I can tell, all OCI type containers. So layer is just a diff. It's a set of changes on top of the previous layer. tar is a bad diff format, right? It's very verbose. The granularity of a change is a file, no matter how large that file is. You can't get random access into a tar because it has no index. You can't pack and unpack a tarball, or you can, but it's very hard to get it to be bit identical. OCI is all about hashes, so in order to work, it has to be bit identical. The layers are also not even tar, right? They're tar with a little extra special sauce on top, specially named files to indicate deletion, called whiteouts. Tar is not mountable, right? You have to unpack it before you can use it. OCI does not standardize which tar you're going to use, right? So there's actually a whole bunch of different kinds of tar. Somebody proposed in 2016 to pick one, and they were told that it was ridiculous and excessive, and the issue was closed. We talked about layers aren't fundamental. It's a orthogonal view, in my opinion. Okay, OCI assumes you have a supervisor process. This means that it's very difficult to write an OCI compliant thing that is either stateless or wants to maintain state without having a running process to do the state things. Deduplication, right? So we talked about how layers are, the tarballs are a diff format. Because they build on top of each other, there's some deduplication in that if a lower layer has a file, the upper layers get it implicitly. But if those two layers don't have any ancestry in common, they cannot deduplicate that file, right? Our build cache can do deduplication across the whole thing. The Dockerfile format, everyone uses it. There's no standard. And then, so something that occurred to me that it could be a little spicy, and I'd like to talk about this more. Perhaps the distribution specification itself is a design flaw. And so here's the reasoning. Image registries contain files, right? Specifically, they contain manifests, and they contain content addressed blobs, right? So the manifest will say, here's some hashes, go find those blobs, right? And you can follow the chain until eventually you have the whole thing, right? There's a specialized protocol for distributing this, right? That's the distribution spec. I mean, maybe it's job security. But why don't we just define a directory structure, right? Linux distributions do this to distribute their packages, right? If we do it that way, now the registry can live anywhere with a shared file system. Now there are details, right? So locking is going to be a thing. This type of thing is always more difficult than you think it might be. But this is a powerful concept. Now we're back into something that already exists, right? And we know how to use it. You can even do it over HTTP if you want. Getting back to simple, not complex. Let's create value, not new stuff. Bugs. So like, in order to upload an image, you actually need to compute two different digests on the registry. And one goes in the manifest, the other goes in the config. You can get HTTP responses that are not of the things you said you were accepting. This doesn't actually violate HTTP, which was surprising to me, but I would much rather get a not acceptable rather than some other response with content I wasn't expecting. Symlinks and hard links are really difficult. That behavior is unspecified or underspecified. So the bottom line in my view is that OCI is an awkward fit for HPC containerization. It also has quality control issues. That said, real-world interoperability, I think, is my priority, right? And we do that, right? I think the two key ways right now is you can push and pull the registries. I had to reverse engineer this because every registry does it a little bit differently. You can't just write to the spec. We can build using Dockerfiles. Some things that are coming soon are image export and import, running OCI bundles. And then eventually I'd like to do layer full push to actually put different layers. And then, okay, container device interface. And I see that we're getting very short on time. This is a standard I do like because it's descriptive. This is how you get stuff like GPU drivers into the images, but we have like 3 minutes, so you'll just have to take my word on it. So we'll go right to the value of uniqueness. So remember I was talking about we take a unique approach, but we try to stay compatible. So thinking about it from a technical perspective, it's a different business model, right? So part of that is the fact that we work, or most of the people that work on Charliecloud are paid to do so by the labs, and so those have a different business model than businesses. Partly it's my opinions. This lets us just explore a different part of the solution space, and I think that's valuable. Also, in general, I think independent implementations of different things are useful. Again, access is a different part of the solution space. I think a lot about how to balance things that work in Unix and HPC with technical novelty. And we really have influenced the field, in my view. Unprivileged containers are our thing, and I think Charliecloud was influential in that. Apptainer and Singularity CDE both do unprivileged build. These links are where they said they did it because of Charliecloud. And I forgot to put Elena's thing here too, but that's also, well, you can take her word for it when she talks. Soft skills, or I don't know, there's things that I like about Charliecloud that I wish more things did, right? So we actually have guiding principles, right? We've thought about them a lot. How many projects do you know of that actually say we have a philosophy of something? Megan, we were talking about different types of dashes. This is a 3M dash.
Why does it need more than one?
We will listen to you, right? So our ambition exceeds our capacity, but we will take you seriously. That's often a problem with vendors, in my view. Delivering value to users is kind of the sole objective. We don't have any shareholders. Nobody's trying to get rich. Humility matters. That's something that I think is important. I also like the opportunity to write jokes and then force my younger colleagues that don't understand them to attempt to tell them. You should. and that's it. We're 2 minutes over, so maybe someone has like one very quick question and we can talk more later. Yeah.
Does your philosophy affect development workflows in containers? Do you see like it being easier or harder? This philosophy to that was sort of a pain point originally in containers. I think was the
Like development, like building your containers?
like you want to do development of your code inside a container.
Oh. I think I would say yes, and the way that comes through is that we try to support various workflows, and so the way that you would do that is you would bind mount the directory containing the code you're working on into the container, and then you should just have all your container tools right there. Though because it's bind mounted, you could also run like an editor externally or something like that. So I don't know if that's convincing or not, but I think so.
I'm a container dude still, so.
Oh, okay. Cool. All right. And so now we switch to our next speaker.